Hello guys, welcome again. Today our topic related to VRF versus Hydronic systems. So let's begin differences between these two systems. VRF system has higher energy consumption. In a study for one building has two systems, one VRF and one Hydronic system, found that in 3 consecutive years of operation that the VRF system had higher energy consumption. We are going to see also much notes about this system in the coming slides. What's VRF system? VRF system, according to ASHRAE 90.1 2013 standard, variable refrigerant flow is an engineered direct expansion DX multi-split system incorporating at least one variable capacity compressor distributing refrigerant through a piping network to multiple indoor fan coil units, each capable of individual zone temperature control through integral zone temperature control devices and common communication network. So there are some limitations that VRF technology imposes on buildings and HVAC systems starting as early as design stages. Comparing HVAC technologies and associated costs. The advantages of hydronic systems over variable refrigerant flow systems. Firstly, life cycle operating costs of hydronic systems were significantly lower than VRF systems. Moreover, use of design envelope technology further reduced ownership costs for hydronic system. So for that, number one, on an annualized basis, hydronic systems offer energy savings of 57% to 84% compared to VRF systems installed in the same building and addressing similar load. Second, hydronic systems required half of the total electrical cooling energy required for moving BTUs. Number three, hydronic systems energy consumption is reduced significantly up to 80%. Less pumping energy used. Last, VRF equipment has an average life of 15 years, whereas hydronic equipment has average of 20 to 25 years. On the second hand, similarly, hydronic systems required a lower first installed cost commitment than VRF. Traditional hydronic systems range from $11.9 per square feet to $31 per square feet for schools and apartment buildings, respectively, whereas for VRF systems ranging from $14.9 per square feet to $34 per square feet for the same installations. 2. Total installed cost of chiller-based hydronic systems is significantly lower than VRF systems for the same capacity. VRF requires all building components to be connected to a single control system through daisy chains. This adds time and cost to installation and commissioning. Last, VRF systems must be oversized to compensate for differences between rated and actual installed capacity. Now let's have a look to the benefits of hydronic systems over the variable refrigerant flow systems. What are the benefits of hydronic systems over variable refrigerant flow? There are actually 12 benefits listed in the ASHRAE Applications Handbook, but we are going to talk about 10 of them. Benefit number 1. Hydronic system can be used with many energy sources. Hydronic heating and cooling system can be adaptable to a wide variety of current and future energy sources. In some cases, 2 or more of these heat sources can be combined in the same system. They can share the load based on the most favorable operating conditions for each source. Likewise, Many options exist as sources of chilled water for hydronic-based cooling systems. They include chillers and heat pumps operating on standard vapor compression refrigeration cycle, as well as gas-fired absorption chillers, and even water drawn from large deep lakes, whereas VRV systems are solely sourced by electricity. Benefit number 2, hydronic systems allow for simpler future modifications. When older commercial or institutional buildings are upgraded, their existing hydronic distribution system or portions of that system may be reusable in combination with a new central plant for producing heated and chilled water. On the other hand, when VRF systems are used, the existing hydronic piping and all hydronic terminal units must either be decommissioned in place or removed from the building. All new copper piping and refrigerant-based terminals units must then be installed to each conditioned space. This can be highly disruptive to the normal use of the building. Benefit number 3, hydronic systems reduce risk associated with refrigerant leaks. It's possible for a leak to develop in either hydronic heating or cooling system or VRF/VRV system. A leak in a hydronic system is generally easy to detect, and the material leaking is just water or a mixture of water and antifreeze. Well-designed hydronic systems provide numerous isolation valves that allow the portion of the system where the leak is to be isolated from the remaining parts of the system. On the other hand, a leak in a VRF system is a serious and potentially dangerous matter. VRF systems contain much more refrigerant compared to hydronic system reserved by typical heat pump or direct expansion chiller. Under certain conditions, a single leak can be responsible for a complete loss of refrigerant from the system. Large refrigerant leaks can require immediate evacuation of the building and intervention of special teams. Refrigerants such as R410A are heavier than air. If a leak develops in the interior portion of VRF/VRV system, the refrigerant could accumulate in the lower portions of rooms with highest concentrations near the floor. Such accumulation will displace air in the room. In spaces with minimal ventilation, it is possible for refrigerant concentrations to reach values that could render occupants unconscious and ultimately lead to suffocation. NCH Standard 15 and 34 define specific refrigerant concentration limits based on pounds of refrigerant per 1,000 cubic feet of interior volume, beyond which acute toxicity is expected. Those designing VRV/VRF systems should verify that the amount of refrigerant that could be lost due to a leak and the smallest space into which this refrigerant could accumulate are in compliance with this standard. Benefit number 4. Hydronic systems use less distribution energy. Although proponents of VRF/VRV systems point out that no circulators are needed to move refrigerant throughout a building, electrical energy is still required just to move refrigerant gas and liquid through piping. That energy is supplied as electrical input to the system's compressors. The electrical energy consumption for moving refrigerant through a VRF system per unit of heat or cooling energy delivered is significantly higher than that required for a well-designed hydronic systems. Let's have a look to this graph, which compares the energy required to move cooling effect through a building. It assumes that the thermal energy is supplied by a vapor compression source such as used in a VRF system. The vertical axis represents the percentage of the compressor power required to move, not to create the cooling effect generated by the refrigeration system. The horizontal axis represents the distance from the thermal energy source, such as the chiller, to the load. The VRV system uses about 6% per 100 feet of refrigerant lines set compared to the Hydronic system, which uses only about 0.3% per 100 feet of distribution distance, e.g. 200 feet total piping circuit length. Benefit number 5. Hydronic distribution systems are not dependent on specific refrigerants. Hydronic systems are not subject to a radical redesign or modification based on future changes in the refrigerants. Over the last 2 decades, highly successful refrigerants such as R22 have to be phased out due to concerns over their global warming potential. Replacement refrigerants have been and continue to be developed. The properties of these replacement refrigerants have mandated changes in components such as refrigerant piping and the oils that are carried throughout the system with the refrigerant. Benefit number 6. Hydronic systems allow easy integration of thermal storage. Many heating and cooling systems can benefit from thermal storage. The high heat capacity of water makes it an ideal thermal storage material for both heating and cooling systems. The heated or chilled water may be produced by heat pumps or chillers at time when off-peak electric utility rates are in effect, which significantly reduces the cost of delivered thermal energy. Water-based thermal storage can also be used in systems that have renewable energy heat sources such as solar thermal collectors, air-to-water heat pumps, or biomass fuel boilers. Combined heat and power (CHP) systems also benefits from water-based thermal storage. Thermal storage is easy to implement when a hydronic heating source and distribution system are used. In many systems, the water that stores thermal energy in a tank can eventually pass through the distribution system without need of any heat exchangers. This eliminates the cost and complexity of the heat exchangers and the thermal penalty imposed by their use. The use of thermal storage for space heating and cooling with VRF systems is not practical. While it is possible to transfer heat from refrigerant to water using heat exchangers, it is not practical to recover that heat back into refrigerant for subsequent delivery to VRF terminal unit. Number 7. Piping options. Hydronic systems can use traditional piping materials such as copper tubing or steel piping. Modern hydronic systems can also use polymer-based piping materials such as PEX or PERT and polypropylene. These piping products are less expensive and generally easier to install than the all-copper piping system required with VRF systems. Benefit number 8. Hydronic systems allow for radiant heating and cooling. Hydronic radiant panel heating has long been recognized for providing unsurpassed thermal comfort. Warm water from a variety of heat sources can be supplied to these panels. They create interior surface temperatures and air temperature profiles that are ideal for human comfort. They operate silently with minimal air movement and deliver heat to spaces using a fraction of the distribution energy required for forced air systems or VRF systems. VRF systems are limited to air as the final means of conveying heat or cooling effect from the refrigerant into heated spaces. As such, they are not well suited to interior spaces with all ceilings or applications where internally generated dust would quickly clog air filters. Benefit number 9. Hydronic systems provide load versatility. In addition to space heating and cooling, hydronic systems can be configured to provide high-capacity domestic water heating, snow melting, and pool heating. These ancillary loads can be prioritized to reduce the total thermal capacity needed. VRF systems are not currently used for such ancillary loads. Benefit number 10. Hydronic systems provide longer life expectancy. A well-designed and properly maintained hydronic heating or cooling system is a long-term investment. Although the life of the original heat source of chiller is approximately 15 to 25 years, the distribution system, e.g. the piping, valves, heat emitters, and terminal units, can usually provide many decades of service. Many hydronic systems that were installed over 50 years ago remain in operation today. The 2015 ASHRAE Applications Handbook lists the medium service life of air-to-air heat pumps and similar refrigeration-based HVAC equipment using fixed-speed compressors and outdoor condensers units at 15 years. Conclusion. For building owners, architects, these and other considerations have relevancy. Design engineers and all those who have a stake in commercial building HVAC system design, installation, operation, and maintenance, those who influence system selection must be diligent in their analysis to ensure systems are code compliant, energy efficient, and adaptable to future energy sources. The most efficient systems in terms of cost, performance, and efficiency will be in demand to help meet energy goals and keep building cost in line. Finally, if you have any comment, question, please write it below the video. Kindly like, share, and subscribe. Thank you for watching.